In the got it section of number 5, again we have to get rid of the i's. I'm hoping you notice that part B will be the easiest one because it has a monomial on the bottom. Let's work with A first. See that 4i on the bottom? We have to get rid of it, and in order to get rid of it, we need to use the conjugate. So we'll do 3 minus 4i. On the top, we FOIL, or multiply together. Let's see what we get as an answer. 5 times 3 is 15. 5 times negative 4 is minus 20i. Negative 2 times 3 is minus 6i. Negative 2 times negative 4 is minus 8i squared. On the bottom, FOIL again, unless you know the shortcut. 3 times 3 is 9. 3 times negative 4 is negative 12i. Positive 4 and positive 3 is a positive 12i. Positive 4 and negative 4 is a minus 16i squared. On the top, minus 8i squared becomes plus 8. And on the bottom, minus 16i squared becomes plus 16. Combine your like terms on the top. 15 and 8 makes 23. Negative 20 and negative 6 makes negative 26i. On the bottom, the 12s cancel out, that should always happen, and 9 plus 16 is 25. Nothing more can reduce, so that is our final answer. I made a mistake. This should be a plus 8 here. This should be a plus 8 here because this is a negative 2 and a negative 4. I apologize. That makes this a minus 8, which makes this 23 a 7 instead of a 23. All right, part B will be a little easier. Just multiply by what you want to get rid of. Some students try to multiply by 6i, which is fine, but it actually makes it a lot harder in the end. You just want to get rid of the I, so just multiply by the I. Distribute in. 4 times I is 4i. Minus I times I is minus I squared. On the bottom, 6i times I is 6i squared. Let's fix the top. Minus I squared turns into plus 1. So the top becomes 1 plus 4i. The bottom becomes a negative 6. Now we should really never have a negative on the bottom, so nothing else cancels, which means I'm just going to take a negative and divide it through every single part, because you really never want a negative on the bottom. Example C, you're going to multiply by, it's a binomial, so you must multiply by the bottom's conjugate. Some students will try to multiply by top and bottom's conjugate. Just remember, you only use the bottom, and then this fraction has to be the same. All right, on the top, let's FOIL. 8 times 8 is 64. 8 times a negative 7 is minus 56i. Negative 7 times 8 is minus 56i again. Negative 7 times negative 7 is positive 49i squared. All over. FOIL the bottom unless you know the shortcut. 8 times 8 is 64. 8 times negative 7 is minus 56i. Positive 7 and positive 8 is positive 56i. And a positive 7 and negative 7 is minus 49i squared. On the top, plus 49 turns into minus 49. On the bottom, minus 49 turns into plus 49 because of the I squared. Let's combine our like terms on the top. 64 minus 49 is 15. And negative 56 and negative 56 makes negative 102i. The bottom, the 56 cancel, and we get 64 plus 49, so we get 113. Just so you know, if you ever check your answers in the back of the book, they may have it separated into two separate fractions. 115 over 113 minus 102 over 113, and they'll probably put the I in the back like that. In problem 6, you have to know how to factor using imaginary numbers. Let's start by pulling out a GCF, which is what you should do all the time. The GCF is 2, which leaves you with x squared plus 16. Now if this was x squared minus 16, as a side note, okay, if it was x squared minus 16, you guys would do x plus 4 and x minus 4. But it's not x squared minus 16, it's x squared plus 16. Alright, if that's the case, you're going to still use plus and minus. You're still going to use 4 and 4. But this time, you're going to use I and I with the 4. And if you want to see why that works out, let's just go ahead. Ready? Under this line, we'll do the check. X times x is x squared. X times negative 4i is minus 4ix. Positive 4i times x is plus 4ix. And then positive 4i and negative 4i is minus 16i squared, which turns into a plus 16. The 4i's would cancel out, and that proves that you would get x squared plus 16. So you guys have always heard of it. So far, you've always heard of it called the difference of perfect squares. And you know how to factor those. But today you learned how to do the sum of perfect squares. Let's try it again. Look at the got it and take out a GCF if you can. You should take out a 5 and you'll be left with x squared plus 4. Why would that be beneficial? Because you know that these are perfect squares. This is the sum of perfect squares. If you ever have the sum of perfect squares, you do x plus and x minus. 4 breaks down to 2 and 2, but because it's the sum of perfect squares, you would need to do 2i and 2i. We're on the last page, and now I think this is actually one of the easier pages of your notes. Finding solutions using imaginary numbers. You're still going to use your quadratic formula. So if you kind of missed the quadratic formula, it's back. And it's really going to be pretty simple. We talked about the basics of imaginary numbers, and you're just going to apply that into your quadratic. Alright, let's say that we have 2x squared minus 3x plus 5. If you can factor that, go for it. But can you? No. There is no way you're ever going to figure out what goes in there. No way you'll figure out what goes in there. If that's the case, you must apply, ready, the quadratic formula. If you can't factor it, use the quadratic formula. You can complete the square if you want, but I find that miserable. Let's go ahead and start with the quadratic. Negative b plus or minus square root of b squared minus 4ac all over 2a. Now let's plug in. Opposite b is a positive 3. Plus or minus the square root of all that stuff in there. B squared minus 4ac all over 2 times a. This should be nothing new to you. The only part that's new to you is when you do the stuff inside, you get a negative inside. You've never seen that. You've never seen when there's a negative number inside. Well guys, the only thing you do is you pull out an I. That's it. You pull out an I. Let's try this in the got it. Alright, you cannot factor this. Okay, there's nothing that you guys are going to be able to think of that will ever factor this. So we're going to use the quadratic formula. Okay, we have A, B, and C. So ready? Opposite B, positive 1, plus or minus the square root of B squared is 1, minus 4 times A, which is 3, times C, which is 2, all over 2 times A, which is 3. Let's keep working that out. That is going to be 1 plus or minus the square root of 1 minus 4 times 3 times 2 is going to be negative 23. All over 6. That's going to be 1 plus or minus I square roots of 23 all over 6. Do a quick check. Does 23 break down at all? Maybe like 4 times anything or 9 times anything? No. 23 does not break down. Nothing reduces. So that's your final answer. Part B is going to be a little bit different because you actually have an answer, a better answer. Okay, so we're going to do negative b, positive 4, plus or minus the square root of b squared is 16, minus 4 times a, which is 1, times c, which is 5, over 2 times a, which is 1. Keep working. That's 4 plus or minus the square root of 16 minus 4 times 1 times 5 is actually 16 minus 20, so that's a negative 4 inside, all over 2. I really hope that you guys know the square root of 4, right? Everybody knows the square root of 4 is 2. So let's keep going. But you knew that without me telling you. 4 plus or minus, now this is 2i, because the square root of 4 is 2, but it's imaginary, all over 2. Now you see all these outside numbers, they each reduce by a factor of 2. Because they each reduce by a factor of 2, we just write 4 plus or minus 1i. The 2's cancel out. I have one extra problem to help you along with your homework. Okay, because I thought A and B were pretty simple. I thought they kind of gave it to you nice and neat. Let's look one that maybe isn't so nice and neat. You have to, you guys remember this, set equal to 0. That's going to be just a basic instinct now, is set these things equal to 0. Which means you have to distribute in. 2x squared minus 6x equals negative 5. And now you have to add 5 over. 2x squared minus 6x plus 5 equals 0. Now it's ready to go. Negative b plus or minus the square root of b squared, 36, minus 4 times a, which is 2, c, which is 5, all over 2a, which is 2 times 2. Let's carry this over. Follow the arrow. That's going to be 6 plus or minus the square root of all of that stuff in there becomes a minus 4. Make sure you know how to add and subtract. All over 4. Well, that's going to equal 6 plus or minus, I know you guys know the square root of 4 is 2. This is the imaginary though, so 2i, all over 4. Every single thing reduces by 2, so you write 3 plus or minus I over 2 as your final answer. So you can see that you can either factor, if you can always factor. I would not use the completing the square. I would always go to quadratic if you don't know how to factor.